Welcome everyone. In this video lecture, we will solve a GATE 1998 question in which we have to find output resistance in a emitter follower circuit. So the question is, this one is the circuit. Okay, so this one is a emitter follower circuit. So in this question, we have to find R naught, the output resistance to the output terminal, and we have to ignore the effect of R1 and R2. So we have to ignore this effect of R1 and R2. So we have to remove this R1 R2 term. So in this question, first of all, we have to draw the AC equivalent circuitry. So first we have to draw AC equivalent circuit. Okay, and beta value is also given R pi. So better to draw hybrid pi model of this circuit. So first this one is our collector, base and emitter. Okay, so I am drawing this one is our R pi, and we can say this one is the base in, and this voltage will be our V pi. Okay, and this from the collector side you can write it Gm V pi, and this end is the collector end. And in AC equivalent model, in a AC equivalent model, we have to make the DC supply to ground. So we have to make the DC supply to ground. DC supply to ground. Okay, to ground. So this one will be this collector and it is just grounded. Basic one. Okay, and now from emitter one there is a resistance. So draw a resistance here. This one is our RE, that is our 1 kilo ohm. So better to write 1 kilo ohm. And this one is a V naught. Okay, and one more resistance is there to the input source. So it will connect it to the base in. So this one is connected to the base in, and the value is 1 kilo ohm, and this one is our Vs. Okay, and V naught, and this one is our V naught. Okay, so for we have to find the output resistance from this in, that is our R naught. The easiest calculation for the output resistance, we have to do one thing. We have to use some test voltage, say some test voltage, say Vt we are adding at the output side, and some corresponding current will be, say, It. Okay, corresponding current It. So R naught value, the R naught value will be simply our Vt by It. So this one we have to find. Okay, and one more thing, for the output impedance, calculation, for the output impedance, or better to say impedance or resistance, because in question it is written resistance, the input source, the input source Vs should be grounded, should be grounded. Okay, so what we are doing, we have to make this one as a ground. Okay, for output impedance. So better to neglect this thing. Okay, for the output impedance calculation. Now one more thing, this current is nothing but simply our IB current, IC current, and this one is IE, and this one I have written IT. So if we apply Kirchhoff's current law, so if we apply by applying Kirchhoff's current law at point E. Okay, by applying Kirchhoff's current law at point E, this point. So what we can write, total incoming current equals total outgoing. So total incoming current at this point will be how much? IE plus IT. So one can write easily IE plus, I have written capital I, so better to write capital I now, IT equals to 0. Okay, or one can simply write IE equals to minus IT. Now this IE, the emitter current, IE is the sum of IB plus IC. So in the next line, I am writing IB plus IC equals to minus IT. Okay. Now this IB current we can write V pi by R pi. If some resistance is there, this resistance value is R pi and this voltage is V pi. So the current, that is our IB V pi by R pi. So it should be our V pi by R pi, and the IC current, IC, this one is nothing but simply GM V pi is our collector current. So we can simply write GM V pi equals to minus IT. Now what we can take common? V pi. So if we are taking V pi as a common, one can write 1 by R pi plus Gm equals to minus IT. Okay, now just think about R pi. So R pi, the resistance looking from the base side, value will be beta by Gm. That formula you have to know. These are the very fundamental formula, like R pi equals to beta plus 1 RE. These are the very important formula. RE alpha by Gm, RE alpha by Gm. These are very important formula. Okay, these three formula we have to remember. Okay, so after this one, after this one can write 1 by R pi. Why I am writing 1 by R pi equals to 1 divided by, you can write one more line, beta by Gm plus Gm equals to minus IT. Then after V pi, Gm will be up, beta plus Gm equals to minus IT. And one more line we can write, we can take Gm B pi as a common, Gm we are also taking common, 1 by beta plus 1 equals to minus IT. Now the beta value is much greater than 1. So this value will be negligible. So we can write it 0. So 1 by beta value will be approximately 0. Okay, 1 by 99 approximately 0. So we can simply write IT value equals to minus Gm V pi. Is it clear? Very simple thing is there. Clear? Beta value is much greater than 1. So 1 by beta is also 0. So this one. So we have applied Kirchhoff's current law at the point, emitter point E. I equals to IT, IB plus IC. Everything we have put it. Then we have solved. Okay. Then what we get? IT equals to minus GM V pi. So suppose this one is our equation number 1. Okay. Now next. Now for the output impedance, I already told we have to make the input source should be grounded. So now what we have to do, we have to apply KVL in this loop. Okay, say loop 1. If we apply KVL in loop 1, okay, so it will give some relationship. So now again I am writing by applying KVL in loop 1. Okay, by applying KVL in loop 1. So what we have to write, this current is nothing but simply IB. So we can write minus 1 kilo ohm into IB. Okay, I am writing like that, means current direction negative. KVL you can use plus or minus depending upon your choice. Okay, convention. Then minus V pi voltage drop, so minus V pi, then minus VT is equal to 0. Okay, minus V pi and minus VT equals to 0. Okay, so now VT can be written as minus 1 kilo. Okay, and IB is V pi by R pi, V pi by R pi. Okay, IB this current V pi by R pi, and this one is also minus V pi. And here it is already given R pi is 1 kilo ohm, so we can cut this 1 kilo ohm with this R pi, because R pi is also 1 kilo ohm in question. So the VT value will be nothing but simply minus 2 V pi. Okay, so now this one is the, okay, minus 2 V pi. Clear? So this one is one more relationship. Okay, now the other relationship, say this one is our equation number 2. Okay, this one is our equation number 2. Clear? So now what we have to find, R naught Vt by It. Okay, so R naught is nothing but simply our Vt by It. So Vt value we can write minus twice times of V pi, and It value is minus Gm V pi. Okay, so this V pi cancel, minus cancel, minus cancel. So it should be twice by Gm. So R naught equals to 2 by Gm is the final result. Now we have to find Gm value. Okay, so in our question it is also given the formula R pi equals to, we have to know R pi equals to beta by Gm. Okay, so beta is given, R pi is given, so Gm will be beta by R pi. So here we can write Gm is nothing but simply beta into R pi. So 2 into 1 kilo. 1 kilo, okay, 1 kilo ohm. R pi is given 1 kilo ohm. That is 1000 ohm. So I am writing this one by 99. So this R naught value is more or less 2000 by 99. So if we solve 2000 by approximately 100, so it will come around 20. So R naught value is 20 ohm. So the final result R naught value 20 ohm. So this one is the R naught value. Okay, so you have to know this formula. Okay, so this is all about this question. So the our final answer for R naught This R naught value will be 20 ohm. Okay. Wait. R naught 20 ohm. Okay, just we are just neglecting this Vs for the output impedance. We are just writing KCL, Kirchhoff's current law at emitter point and applying KVL. Then we have to find Vt by It for the output impedance. So the final one will be 20 ohm. So this is all about this question. So you have to go step by step for this question. Only apply KCL and KPL and you can easily find the output resistance. Here we are saying output resistance. This R1, R2 are we have to neglect because already given, so the question is much easier. So this is all about this question. So thank you for watching this video.